Hello, my name is Kevin Pearies. I am a Senior Applications Engineer at Exfo. And today, I'll be covering the Max 715B iOLM setup, saving, and reporting. So let's go ahead and jump right in. I'm going to go ahead and switch over to my Max 715B interface here. And over here to the left, I see configuration here. So I'm going to go ahead and check the software version that I'm on. So when you are watching this video, you'll know at least what version I was using. So I'm going to go ahead and select configuration there. And then from configurations, I'll go down or go up rather to system or software updates rather. So right here where it says software updates, and I'll select that. And then here are the versions that I'm on. So right now I'm on system image 2.3, OTDR iOLM 8.34. So that's the versions I'm using for this training. So now that we opened up in the main iOLM tab, first thing I need to do is set up the unit. So over to the right under the main menu structure, I'm actually going to start at the bottom here with user preferences and kind of work my way up. So I'm going to select user preferences here. And then the first thing I'm going to do is I want to hit revert to factory settings. That way it gets me back to a known state. So I'm going to go ahead and do that. And then from here, I'll tweak the settings that I'd like. So the first thing I look at is where do I save my files? And right now it's under my documents.iolm. If I wanted to change that location, then I would select the icon to the right, and that allows me to change my save to directory. If I want to save an SOR file, so an OTDR file along with my iOLM trace, I can select that here. So this allows me to save a file as a Bell Core Standard SOR, so which is a nice option if you want that. In this case, I'm going to leave that off. I'm also going to leave off report generation, which generates a PDF when you save the files. I'm also going to turn off automatically save measurements. So what this does is it automatically saves a measurement after every test. I normally leave this off because I want to, if I have to retest, I don't want to have to roll back to incrementation. You can also set it for only if it passes to kind of ease up that kind of, that kind of confusion. And then down at the bottom here are some additional settings. Turn on the sound. I like to see the fiber section information, cumulative loss, whether you want to turn that on or off. In this case, I'll turn it on in this example here. And then if I have the real-time functionality, so if I don't have OTDR, we have the ability to do OTDR real-time. If you want that button next to the start button, that's what this does, right? It activates whether or not that button is going to be present for you. In this case here, I'll just leave it populated. And then down at the bottom here, I can set my, my distance units. So I'm going to leave this one at kilometers. And then I'm going to go ahead and apply, and then OK. And so that sets up my user preferences. Now I'm going to set up my test configuration. So just above user preferences, I'll select test configuration. And iOLM, one of its big strengths is analyzing the data. So how does it know whether or not a splice is good or bad? How does it know what type of elements are in the system? That's by configurations. So setting the thresholds and some other details about what we're going to test, we do under configuration. So what I do to create my own configuration is I'll highlight default configuration, which is already selected here. I'll go down to the bottom where it says duplicate, and I'll create a new one, and I'll give this one a name. And here I'll just call it the iOLM demo, and then hit enter. And then I'll save it. And then you'll see now we have this new iOLM demo, and it's selected. Now from there, I'll go down to the bottom here and select modify. And then from modify, I'll go ahead and start setting it up. So this first one is port. If right now it's set for unspecified, meaning when the tester loads this configuration and starts a test, they will have the ability to select what wavelengths they want to test, which port they want to test out of. In this Max 715 that I have, there's only two wavelengths, 1310 and 1550. So if I'm going to make sure and force them to use both wavelengths, then I'll lock it into the configuration and they won't have a choice. In this case, I'm just going to leave it at unspecified. Opto mode is essentially some custom configurations that we've made. So fast short link allows you to test short links, or roughly around 8,000 feet or less. It optimizes the trace so they get actually done faster. Pond last mile certification adds some elements for working in a pond environment with splitters and whatnot. And so some of these might be options on the units, the iAdvance options. In this case here, I'm just going to leave it at none. Over here to the right, you see SOR Pulse Editor. So we have the ability now to, when we generate an SOR, to select the specific pulse width that we want to use. Right now it's going to use auto, but you could also define one. You can say, I want to do a short shot SOR, so give me something at 5 nanoseconds. So we can do that. In this case here, I'm just going to leave it right where it's at and then hit OK. Link definitions. So if I wanted to define my own custom elements, if I wanted to set an index of refraction, this is where we're going to do that. This is where you can input custom elements. So if you have a particular type of device in your system that has a specific loss value, say like a CIPRI interface couple, or you want to create an event for pigtail connectors. So basically a connector that has a pigtail splice close by that merges, then you can do that here with the custom element. And then this very last one here is iOLM pass fail. So this is where we can set our pass fail thresholds. And again, these settings will vary depending on your organization, depending on your practices, your processes, customer requirements, those types of things. In this situation, I'm going to go ahead and set 1310. And what I usually do is I don't really set link loss thresholds, because the loss will vary depending on the span you're working on. Unless you're working an engineered budget system like fiber to the home, where it might be budgeted at 30 dB or better, or 25 dB or better. Normally, I just set this at max. So I'll set this at the max value, which is 99. ORL, I do care about. And so ORL in this particular situation, I do care about it. So I'll set this at usually somewhere between 28 and 32 dB. So in this case here, I'll set it at 28. And for link length, I just set this at 300 kilometers. And I'm doing that just so I don't get any false fails. Then I'll go ahead and hit enter. And then the splice loss and the connector loss, I'll leave right where it's at 1310. And the max reflection, this will vary depending on your organization. We typically see it between neg 40 and neg 50 dB. Neg 50 is better than neg 40. So, please refer to your local practices and customer requirements. Then I'll set something for 1550, and I'm essentially going to do the same thing. So at 1550, the top's already done for me. I'm going to set my splice loss in this example to 0.2. And then I'll set my connector loss to 0.5. I set 1310 a little bit higher because 1310 does have more loss or attenuation per span, per kilometer, per connector, per splice. 1310 has a higher loss than 1550. If it doesn't, then you have a pinch or a macro bend in the system. I'm going to go ahead and set the reflection at minus 45. So I have that set at minus 45 here. And once I'm done, I hit OK, and my configuration is now created. And so I can create configurations for different types of applications, PON F2, a fiber to the antenna, specific customer requirements. So you can do that and then just load those configurations, and the unit's already set. So in this, I'll make sure that it's selected, and you see iOLM demo here. I'll hit close, and down at the very bottom left, we see that it is selected, right? We have iOLM demo selected. That's the configuration we're using. And so that's how you set up a quick configuration with iOLM. Now I'm going to set up the identifiers or identification. So over in the right again, I'll select identification, and this is where we set our naming convention and really identify the headers and the information. Where are we testing? Where we're testing from, where we're testing to, what's the fiber number, all of that stuff. And so again, hit factory default on this if it's the first time you're using it. And then essentially I just start at the top and just start putting in information here, whatever's relevant. And so as I populate this, you can see how it's going. So I'll put my name in here. If I have any comments, I can add that. Let me scroll down a little bit here. Cable ID. So if you're testing between two sites and there's multiple cables, then you have to identify which cable you're on. So however that cable is identified, I'll go and put that in there. And then fiber. So this is where we're starting. And so this is the prefix. You can put in the word fiber. You can put in the word connector, port. I like to leave mine blank. And then whatever my starting incrementation is, I'll go ahead and put it there. If I'm starting on fiber number 1 or fiber number 432, this is where you put that information, right? And so in this case, I'm going to leave it at 1. And you'll notice it's none and none here for identifiers underneath that. So for this first identifier here, this is my location A. So I'll type that in. I can also do the drop down. So there's a drop down in here. So I can drop this down to location B. So now I got my location set. And then I can put in the information here. So I'll put in just a made up silly code. So I live in Goodyear, Arizona. So I'm going to put in, Goodyear, Arizona, etc. And I'm testing to Phoenix. So that's how we have it set. So right now, and I populate as much information as I want. If I want a fifth identifier, I can use this fifth identifier. But if you look at the file name prefix, or preview rather, this doesn't tell us a lot. If I save this now, it'll be 1.iolm. That really doesn't tell me a whole lot, right? So what I'm going to do is I'm going to use some of the other identifiers that I populated to complete my naming convention, right? And so if you look over here to the right, under file name, you can see these option of checkboxes. So these checkboxes will add these values from the identifiers within the file name. So I want to add the location A, the location B, the cable ID, and then now here's the file name preview. So it's a lot more comprehensive. Now, I'm pretty picky about my order. I like to go location A, location B, cable ID, fiber ID. And so in this case here, over here to the right where we have these arrows, we can change the ordering. So I'm going to move this down to there. And then I want fiber ID underneath that at the very end. So now you look at the naming convention. There's my location A, B, cable ID, fiber ID. One thing that I want to make sure and change is you see there's a single digit there for the fiber ID. I'd like to use 4 digits. We're seeing a lot more, 1728 fibers, 3456s. So I want to have a 4-digit identifier or value. So I'm going to go ahead and fiber ID here. And over to the right under format, I'm going to select this pound sign and add 4. And then when I select off of it, it'll give me the option to change my stop increment to 9,999. And then I hit OK. And then now here's our final identifier. This is incredibly important to have a really good identifier because when you're saving the information, this will help whoever's managing the reports or locating this data to understand exactly what they're looking at. And so we're testing from Goodyear to Phoenix, cable 2, fiber number 1, and we're counting up from there. And so I'm going to go ahead and hit OK. And that's how you set up your identifiers. Now we can go ahead and hit the Start iOLM button up here at the top to begin the test. So I'm going to go and hit that. And what's going to happen is iOLM is going to send out multiple acquisitions at multiple post width, at multiple averaging time, and kind of stitch that information together. So you'll always see an event at, say, 50 feet, and you'll always see an event at 50 miles. And so it's like having a short shot, a mid shot, intermediate shot, long range shot, all in one shot. And so it's very amazing. And so as it starts to gather data, you'll see these blocks start to populate here. And up here, you see the top, it says global fail here. Wait until the test is done. So down at the bottom, you can see the progress bar kind of filling up. And so as iOLM gathers more and more data, it'll start to, correlate the information, compare it to the other shots that it's using at different resolutions. And this fail may stay on or it may go away. And so we'll wait till the very end here. And so as the trace starts to finish up here in the bottom right, we can start seeing the results starting to settle in a little bit. And you'll see these grouped events over here to the center right. These will start to pull apart, and there they go. And then once the trace is done, you'll hear an audible tone if you had the sound turned on, which I just heard. And then all of a sudden, a bunch of colors pop up in front of you. And so this is the actual test itself. So let's start analyzing the data real quick. So first of all, let's look at the screen here. So to kind of break it up, so this portion up here is really the display. So what we're looking at here is, this is the distance, so the span length. This is the port on the iOLM. You'll see the negative value there because we zeroed out the launch cable. This is the first panel or the first connector at the end of the launch cable. And then we start seeing connectors going through here, right? And then if you start looking at these values here, so this is the element number. This is right underneath it is the distance to that element. So this is 0 footage. This is basically 20 meters. I have a connector at 20 meters after the beginning. Then I have another one at 170 meters. So you kind of see the distances there as it progresses along. Down here is the length between the elements. So 20 meters, 149 meters, 10 meters. So I have a jumper here is what I have there. And so that's what we're looking at there. So as we select an event, we can see what they start to look like. I usually select the first event, which is my launch, just to verify I'm getting good launch. So I want to see these values for reflection. I want to see them very high. I like to see, for an APC connector that I have on mine, I expect to see neg 60s or better. In fact, the 1310 is above sensitivity, so it's even better. And of course, we're looking at the results here. We're seeing the type of event. So this is span start. This is where it's at. And then, of course, the loss at each wavelength, and then the reflection at each wavelength. And we set the pass-fail for the reflection of minus 45. Now, this one's gray. It's gray because we're not analyzing it, because it's not in our network. We are starting analysis right here where it says A. So this means this is the A connector, so the very beginning here. And so if we look at this and select this A connector, it'll populate down here. This is our patch panel. This is usually where we see the most amount of fails, is where we plug in the launch cable to the FDP. So we really want to validate this while we're on site. And so looking at this value here, we see that it's a connector. We see it's the location A. It is the A connector, so that's the A side connector. We see the loss values, and then most importantly, what I see fail most is reflection. In our system, we set the reflection at minus 45 dB or better is what we set it for. So this is this is better than that, right? We want to see a higher value. Neg 50 is better than neg 45, you know. And so for UPC connectors, I expect about a neg 50. For APC connectors, I usually expect up in the neg 65s, even out of sensitivity. It doesn't even show reflection sometimes. And so that's what we're looking at here. So at this point, we're just analyzing data. We're just analyzing data and looking to see what we have here. That's basically all that we're doing here. And you notice this one here has got a gainer. So it's got a gain in power of a negative value. What's happening here, so this is why it's important to understand your network. What's happening here is we're going from standard G.652 fiber. I'm sorry, I got standard G.652 fiber going all the way through here. And then once we get to this connector, we switch over to bend sensitive fiber, and then back over to G.652 standard fiber. So it's a change in fiber type, so change in mode field diameter. So we're seeing in one direction a gain in power, and in the other direction, an exaggerated loss. And so the only way to get this information correctly, to get a good reading for either one of these connectors, is to look at both sides. So a bidirectional test and average it out. So anytime you have a gainer on one side, you're most likely going to have a loser on the other if you're switching back to the fiber. So this one here tells us this connector bulkhead is damaged, dirty, or not well connected. So you see where it's got a 0.503. It just barely fails. But this is an exaggerated loser. And again, and so if you want to scroll across, we kind of scroll across here with this arrow on the right, and we can look across the span. This right here happens to be, an APC connector, not a splice. So if we look down here at the analysis, make sure that the fiber is properly spliced, right? But below it says this could also be a low reflections APC connector. So it's smart enough to know that it might be an APC. So I can actually drop down here and change my type from a splice to a connector, and it'll reevaluate it as a connector. And so that's a nice little feature there, because we're seeing a lot of APCs identify as connectors in the system. And so that's what we're seeing here. And so we're just kind of scrolling through the system to see what we have. And then from here, we're just saving the data. So we'll save the trace. And then it'll increment to fiber number 2 on the next one. If I want to generate a PDF report, I'll just hit the report here on the top right, and then I can generate a PDF and have it save to my hard drive so I can email that to somebody right away. And then from here, I'm just, unplugging from the patch panel, inspecting, cleaning my connector as needed, and then testing on and on and on and on. And that's pretty much in a nutshell. That is testing with the MAX 715B, the setup, the saving, and the reporting. My name is Kevin Pearies. Thank you very much.